Welcome, space enthusiasts and curious minds alike. Today, we're on the brink of a new chapter in space exploration. Join us on Cosmic Era, where we witness history in the making with the awe-inspiring launch of the Vulcan Centaur rocket. Vulcan Centaur, the next-generation heavy-lift rocket from United Launch Alliance, made its debut early Monday morning. It was a successful first launches for the long-awaited rocket, but the customer spacecraft from Astrobotic experienced a propulsion failure after deployment. The Vulcan EST from Space Launch Complex 41 at Cape Canaveral Space Force Station. The rocket uses liquefied natural gas (LNG) / methane fuel booster powered by a pair of B4 engines provided by Blue Origin and two graphite epoxy motor GEM 63XL solid rocket boosters provided by Northrop Grumman. Vulcan will provide high performance and affordability while continuing to deliver our superior reliability and orbital precision for all our customers across the national security, civil, and commercial markets. Vulcan continues the legacy of Atlas as the world's only high-energy architecture rocket. I am sure you were thinking about the purpose to design Vulcan Centaur. Vulcan Centaur is a rocket created by United Launch Alliance, ULA. It is designed for the U.S. government's National Security Space Launch (NSSL) program for use by the United States Space Force and U.S. intelligence agencies for national security satellite launches. It will replace both of ULA's existing heavy-lift launch systems, Atlas V and Delta IV Heavy, due to their retirement. Vulcan Centaur will also be used for commercial launches, including an order for 38 launches from Kuiper Systems. Size and weight of Vulcan Centaur. If we are talking about the size of these vehicles will be compared. The Atlas V is up to 58.3 meters tall, depending on fairing configuration, with the core being 3.8 meters wide. The Delta IV Heavy is 72 meters tall, with each side core being 5 meters wide. Vulcan is significantly wider at 5.4 meters and 61.2 meters tall and 546,700 kilograms, 1,205,300 pounds weight. Let me tell you about the background journey of invention and development of the Vulcan rocket that started in 2014, largely in response to growing competition from SpaceX and a desire to phase out the Russian Argu-180 used on the Atlas V. Initially scheduled for an inaugural flight in 2020, the program was delayed by over 3 years due to problems with the development of the B4 engine and the new Centaur upper stage, and finally the first launch began. When the Vulcan first time successfully launched, Vulcan Centaur launched for the first time on 8 January 2024, successfully carrying Astrobotic Technologies' Peregrine lunar lander, the first mission on NASA's Commercial Lunar Payload Services (CLPS) program. United Launch Alliance's ULA new, long-awaited rocket is all set to lift off for the first time ever. But will the vehicle establish itself in a competitive launch market? The Vulcan Centaur is scheduled to launch from Florida's Cape Canaveral Space Force Station early Monday morning, January 8. Aboard will be the private Peregrine moon lander, part of NASA's Commercial Lunar Payload Services (CLPS) initiative and manufactured by Pittsburgh-based firm Astrobotic. The launch is a big deal in itself. It could lead to the first successful private moon landing. Conversely, it could cast a shadow over NASA's lunar program and Astrobotic and bring further delays and questions over the Vulcan Centaur. It is also unusually demanding for a debut launch. The rocket must not only reach orbit, but then kick on and execute a translunar injection burn with its Centaur upper stage. A pillar of exhaust trailed Vulcan as the 202-foot-tall, 62 meters, rocket rose above its launch tower and disappeared into the dark Florida sky. About 2 minutes after liftoff, the SRBs successfully separated from Vulcan's first stage booster, which continued to climb through Earth's atmosphere. About 5 minutes after liftoff, Vulcan's first stage shut its engines down and separated from the Centaur upper stage, which began the first of 3 burns after a 15-second coast phase. Centaur's first burn lasted about 30 seconds, followed by a longer 4-minute translunar injection burn a half-hour later. About 50.5 minutes after launch, the rocket's primary payload, Peregrine, was released to journey onward toward the moon. Furthermore, the Centaur upper stage is half the thickness of a dime. If upper stages are made from flat stainless steel sheet metal and not orthogrid, then what is keeping it from buckling during launch from the huge axial loads and pressure differential when the Vulcan Centaur starts tilting? I must be missing something because this sounds too good to be true. Even if the pressurization gives it strength during launch, it still needs to be structurally rigid when the upper stage is deployed and the thrusters start firing. At this stage, the tanks will lose pressure. Do the fuel tank and oxidizer tank form the outer shell of the upper stage, or are they placed within a cylindrical shell with structural reinforcements? I know the aft end near the nozzles has foam insulation. Testing and development. Vulcan lifted off the first time on 8 January 2024, successfully delivering the Peregrine lander on a trajectory to the moon. It used the VC-2S configuration, with 2 solid rocket boosters and a standard-length fairing. After payload separation following a 4-minute-long trans-lunar injection burn, the Centaur upper stage was sent to a heliocentric orbit after it fired for a third time 1 hour and 18 minutes into the flight to test how it would behave in extended duration missions, such as those required to send payloads directly to geostationary orbit. While the Peregrine lander had a failure in its propulsion system shortly after separation that prevented it from landing on the moon, Astrobotic noted that the Vulcan Centaur rocket performed without issues, and there was no evidence that the failure in the spacecraft was caused by the launch. Let's discuss about the capability of Vulcan Centaur. The Centaur upper stage is 5.4 meters, 17.7 feet in diameter and 11.7 meters, 38.5 feet, long with a 120,000 pounds propellant capacity. Its propellant tanks are constructed of pressure-stabilized, corrosion-resistant stainless steel. Centaur is a liquid hydrogen/liquid oxygen-fueled vehicle. Engine used in Vulcan Centaur. When the rocket's 2 solid rocket boosters, SRBs, and 2 Blue Origin-built B4 first-stage engines blasted the vehicle skyward with nearly 2 million pounds of thrust. Atop the rocket was Pittsburgh-based company Astrobotic's Peregrine moon lander, which is carrying 20 different customer payloads, including 5 NASA science instruments. 2 interstage adapters connect the first stage of the Atlas with its Centaur upper stage. The Centaur has a restartable RL-10 engine from Pratt & Whitney Rocketdyne. This engine uses liquid hydrogen and liquid oxygen and can provide up to about 22,300 pounds, 99,200 of thrust. The Centaur can control its orientation precisely, which is important for managing the direction of thrust while its engine is firing. It carries its own flight control computer and can release its payload with a desired attitude and spin rate. Furthermore, the mission design and performance of Vulcan Centaur is a versatile launch system capable of delivering payloads to a wide variety of orbits, from high-inclination polar low Earth orbits and highly eccentric Molniya orbits out of Vandenberg Space Force Base (VSFB) to low and medium Earth orbits, geostationary transfer, geosynchronous orbits, trans-lunar injection, and high-energy Earth escape orbits out of Cape Canaveral Space Force Station (CCSSS). The Vulcan Centaur mission design can also be optimized to meet a broad range of customer mission-specific requirements. Performance capabilities quoted in this document are presented in terms of payload systems weight, PSW. PSW is defined as the combined mass to orbit of the separated payload, the payload to Vulcan Centaur adapter, and other mission-specific hardware required on Vulcan Centaur to support the payload EG RF radiation system, payload instrument purge, mission-specific harnessing. Propellant reserves are held back to cover estimated 2.33 sigma Vulcan Centaur performance dispersions. Wait, are you thinking about the reliability of Vulcan Centaur? I am telling you about Vulcan Centaur reliability. The Vulcan Centaur reliability model is directly derived from the Atlas and Delta reliability models and mission histories. Vulcan Centaur combines decades of engineering experience, proven design knowledge, manufacturing and launch efficiencies, and robust risk reduction methods to achieve the best value for your mission. Vulcan Centaur is an evolution of the flight-proven, highly successful Atlas V and Delta IV launch vehicles. The introduction of a careful balance of new technologies and innovative features, additive manufacturing, advanced welding and inspection processes, and many others ensures a reliable and affordable space launch service. Total cost. ULA had not yet estimated the total cost of development, but CEO Torrid Bruno noted new rockets typically cost $2 billion, including $1 billion for the main engine. In March 2018, Torrid Bruno said the Vulcan Centaur had been 75% privately funded up to that point. In October 2018, following a request for proposals and technical evaluation, ULA was awarded $967 million to develop a prototype Vulcan launch system as part of the National Security Space Launch Program. Conclusion. As we can call that United Launch Alliance leaders and engineers completed an important milestone with the conclusion of the system-critical design of new Vulcan Centaur rocket. When the first Vulcan Centaur rocket flies in less than 2 years, a high percentage of the rocket will have flown before on ULA's Atlas launch vehicle, including the fairing, upper stage engines in a dual configuration, avionics, software, and solid rocket motors. Vulcan Centaur brings together the best of Atlas and Delta technology, and that is flying all of the major components that we can on Atlas V first to reduce the risk for our customers on the first flight.